Hello everyone, this presentation is for poster presentation, PEC annual conference in 2025. The topic is hybrid Droop-Based control for parallel operation of DC-DC converters in a DC microgrid. My name is Naser Souri and I am a research assistant at Regal Lab, and my research interests are modeling, control, and stability of AC and DC microgrids, plus converter modeling and control. One of the challenges in a DC microgrid is power sharing when parallel converters are connected together, and any difference in the size or length of the cables that connect the DC-DC converters to a load bus can cause different VI characteristics from no load to full load, and then it can cause unequal power sharing. Plus, any difference in the voltage at the terminal of the converters can cause a circulating current between the converters. Circulating current does not contribute to the actual load and circulates between the converters. The output currents are obtained using the two-port network that you can see in the figure, and the currents are calculated uh, in these equations. And the second term is the circulating current, and it depends on the terminal voltage of the converters. Another consequence of circulating current is that losses are not distributed equally. As you can see, they are unequal. And this figure shows the circulating current ratio versus current ratio, or I1 to I2. Our proposed method is to use hybrid Droop control, to use a constant Droop gain plus a Droop voltage corrector to compensate for the conventional Droop control. It means that we can correct the reference voltage with advanced Droop control, as you can see in this block diagram. Then an adaptive integral controller is used to create a corrector voltage, and it depends on only the difference between the current, the reference current, and the output current of the converter. The figure on the right hand side at the bottom, it shows the stability, it shows the frequency response of the converter, which ensures the stability of the converter. To validate the proposed method, simulation result shown in this figure, in this slide. Simulation studies are performed in MATLAB Simulink for two bulk DC-DC converters. In the first case study, power sharing activation is tested, and the figure, as you can see, after activation they can share equal power, and the current difference between the converters gets zero. And the second case study shows proportional power sharing and load change. As you can see, at uh, zero point 0.2 and zero point 0.5 second, proportional power sharing is activated, and then at 0.7 second, the load has changed, and the converter can respond to the command correctly. This slide shows the test bed for experimental test. Two bulk DC-DC converters are built to validate the proposed method, and the communication delay is 5 milliseconds. This slide shows the experimental result. Similar to simulation result, two case studies for power sharing and proportional power sharing is tested. In the first case study, as you can see at this point, the power sharing method is activated, and then they can share equal power, and the controller adjusts the voltage of the converter. In the second case study, proportional power sharing is tested. For two different times, uh, the command is sent to the converter to share unequal or proportional power sharing, and the converters can follow the command correctly. So a hybrid road control is proposed for power sharing in DC microgrid. The proposed method adjusts the reference voltages for power sharing, and then the simulation and the experimental results shows a fast response for power sharing in all cases, and also the settling time is reduced by 40% compared with no compensator in the controller, and the overshoot is reduced by 2.5%.